Okay, what we're looking at is a B&K 1535 35 megahertz dual trace scope. We measure horizontal sweep times going from zero point 0.5 seconds per division up to zero point 0.1 microseconds per division, and we do that in like 23 range steps. We will measure our vertical amplitude from 10 volts per division to 2 millivolts per division, and we do that in 6, 9, 12 range settings on both A and B channels. We have a mode switch that allows us to go channel A, channel B, both channels together, additive where we add the two channels, or we can subtract. What I'm going to do right now is we're going to take ourselves through a DC voltage check of the vertical channels and see how the vertical channels react to a known DC voltage. We're going to apply the voltage from this analogic DC voltage standard, which provides accurate DC voltages, and then we're going to observe how many divisions that we see in response on the scope. And once we've determined what the vertical response is, if it's accurate, then we'll go for the time base. So right now we're on channel A. We're at ground. We're checking to see that we are properly zeroed out. Yeah, that looks to be good. We are on the lowest setting. That's 2 millivolts per division. I'm coming through a divide by 10 probe, and so I'm going to be applying voltages that are 10 times higher than what the scope actually sees. That will reduce our noise content, and we'll like that. So like right now, I'm going to be applying a millivolt to the scope, and it's going to take, we're going to go up a half a division for a millivolt. It's going to take 2 millivolts to go a division. Ourselves in DC. Here is half. Here's a division. Here's the next half. There's 2 divisions, so that's 4 millivolts. Here's the next half. 3 divisions. Next half and 4 divisions. Alright. Then we will go to the next position. This is the 5 millivolts per division step. And in this case, I'm going to apply a millivolt. It's going to take, so I'm going to go 1/5 the division. It's going to take 5 of these to go up a full division. So here's 1, 2, 3, 4, 5. There's your first division. 6, 7, 8, 9, and 10. There's your second division. And we did just fine. Alright, let's go to 10 millivolts per division. Alright, now we will go, should go a division at a time in this case. So here's 1, 2, 3, 4. Alright, 20 millivolts per division. We will go half a division at a time. There's half, there's 1 division, it's 20 millivolts. 30, 40 millivolts, 50, 60 millivolts, 70, 80 millivolts. Alright, 50 millivolts per division, and we will go up 2 divisions at a time. Let's see. There's 2, 4. Alright. It's because we went up 1/10 of a volt at a time. Alright. Now we're going to go to the direct probe. We're taking the divide by 10 off, and we'll go to 0.1 volts per division. Appears to be zeroed, and we should go a division at a time. Here's 0.1, 0.2, 0.3, 0.4 volts. And then we go 0.2 volts per division. Should be a half a step. There's 0.2, 3, 4, 5, 6, 7, and 8. Okay. 0.5 volts per division. We will go 2 divisions at a time. So we're going 1 volt at a time. 1 volt per division. We should go up 1 division a step. 1, 2, 3, 4. 2 volts per division. There's a half. There's 2 volts, 3, 4 volts, 5, 6 volts, 7, 8 volts. And we have 5 volts per division. I'm limited as to what I can do here, but here's 1, 2, 3, 4, 5. There's 5 volts, 6, 7, 8, 9, and 10 volts. 2 divisions, just exactly what should have been. And then 10 volts per division. We'll be able to get 1 division out of this. Here's 1 volt, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There's 1 division. So we did just fine on channel A. Everything looked great. We're going to move now to channel B. Zero ourselves out here. There we go. Okay. Put ourselves onto, we're going to put ourselves in the divide by 10 position again. Go into DC mode, and we should be going half a division, whole division. That would be 2 millivolts, 3 millivolts, 4 millivolts, 5, 6 millivolts, 7, 8 millivolts. Okay. We are now on 5 millivolts per division, and we should go 2 at a time. 2 divisions at a time. So there's 0.1, that'd be 0.01, 0.02 volts. 10 millivolts per division. Alright, there's 1 division, 2, 3, 4. 20 millivolts per division. 20 millivolts per division, we should go up half a step at a time. Half, 20, 30, 40, 50, 60, 70, 80. Okay. $50 millivolts a division. And we should go 2 steps at a time. 1, 50 millivolts, 100 millivolts. All right. 0.1 per division. We're going to remove the divide by 10. Go direct on the probe. Do that with this. There we go. And now we will go one division at a time. There's 0.1, 0.2, 3, and 4. No problem. 0.2 volts per division. Here's half. 0.2, 3, 4, 5, 6, 7, and 8. And we are at 0.5 volts per division, and we should go up 2 at a time. There's 2 divisions, 4 divisions. Okay. We are on 1 volt per division. We'll go up 1 step at a time. There's 1 volt, 2 volts, 3 volts, 4 volts. 2 volts per division. Alright, there's half, 2 volts, 3, 4 volts, 5, 6 volts, 7, 8 volts. Alright. 5 volts per division. And we will go up a fifth at a time. There's 1, 2, 3, 4, 5. There's 1 division, 5 volts, 6, 7, 8, 9, 10 divisions. Or, I mean 10 volts, 2 divisions. Okay, and then the last step. Got it zeroed. We will go a tenth at a time, or a tenth of a volt at a time. 1, 2, 3, what's it? 4, 5, a volt at a time, excuse me. 6, 7, 8, 9, and here's 10 volts at 1 division, which is as expected. Then we can't go any higher. We're at the end of our range of the analogic, so both channels checked out, and we look good. Let's move on to the horizontal time base.